Okay, guys. So I think that was pretty cool, and then we're ready to to get it done. Now there is one thing here, guys. The thing is that first of all, this guy that we just opened, right? The second stage, it says that it is a DLL. There are many ways to know if it is a DLL. For example, you don't have an entry point. Why? Because in .NET, DLLs, those are also classes, but different with a normal assembly, which has a main function. These guys doesn't have a main function. So that's why there is no entry point option. Also, you can double check by opening up that guy. Here it is. Either way, it doesn't matter. And then we go to the file header, characteristics, and you can see that it says file is a DLL. So we confirm that. So why is that important? It's important because this guy is not standalone. In other words, we cannot debug it right now. So if I wanna, debug it from here, it's not gonna allow me because there is no entry point. Okay, so we need to know what is the entry point of this guy, because even though this class is just to deobfuscate malware, the next step for you is to know where is the entry point so that you can start understanding the behavior and get the IOCs and everything, right? So we know by understanding the reflection that after load, eventually it should call create instance or similar, and eventually invoke member or similar. And if we remember, those calls has the method and the class to be called. So if we go and debug that part, we might find what is the entry point across these different classes. Okay, so now in order to do that, guys, it comes a very good way to use WinDBG and dnSpy in combination. Okay, so let's do it. So here in WinDBG, we are where we just, if you remember, we just load the binary from memory. Okay, so what I'm gonna do right now, guys, is I'm gonna run a command which is called exclamation u dot. This is gonna disassemble wherever we are loaded, but with managed code features. So as you can see, it says pre-JIT generated code. By the way, did I explain you this pre-JIT? Oh yeah, I explained you, right? So no, I didn't explain you. So just quickly, so the pre-JIT, guys, this column, as I told you, this is the entry, the address where it is loaded, the method name, so that we can label them and put breakpoints on them, or get the information about them. So then we have the JIT. Here, this pre-JIT means that these guys were already pre-compiled, so they don't need to go to JIT. It's basically that. And then here the none ones is saying that this has not been JIT yet. So eventually, as I told you before, as soon as this get is being called in memory, JIT is going to process it and it's going to compile it and create the native code and execute it. Okay, and then if this guy keeps being called, it's just going to use a cache mechanism so that it doesn't recompile it every single time, just once. Okay, that was very important. Okay, so then back here, guys, and what I'm gonna do is I'm really interested to know which function calls this load guy, right? So that we can know who called it and start tracing back. Okay, so what I'm gonna do because of that is I'm gonna do an F10 here to execute this guy. See, you see it? We execute it. Now I'm gonna do a PT. PT means go to the return address because I want to get out of this function. Okay, enter. So we go to the return address as expected. Now I do a P, which is just another step into, and we get out of that load instruction, as you can see it here, right? This is the call, and finally we're out of that. So if I here, guys, run again the exclamation U dot enter. Check this beauty, guys. Here it's telling us, you know where you are. You are here in epin self fjk which is the class and the method. And see this beauty, guys. We are getting exactly the names of the functions, classes, and methods. So now we can go back to this guy, and let me just put it this so that we can see it. So we can go now to this guy, to the stage 1, find that namespace, which is this epen, then find the class, and then finally find the KBT, which is here. And check this, guys. We found this dem load that, as you remember, we were trying to find before, but was a total mess. Plus, as you can see, these arguments are obfuscated also, and sometimes even the assembly is obfuscated, so you don't even find it. Okay? So now that we got that, guys, we are more into a position where we can now jump back into dnSpy and start debugging from there, because I mean, it's great and you can debug here definitely, but you need to take advantage that here you have source code. It's easier to read, it's easier to understand. So why you wanna go crazy? I mean, if it is needed, you need to go, but there are always better ways. So you can always pick the best and the fast way. Okay, guys, so now here, what I'm gonna do is I'm gonna put a breakpoint in this load guy, and then I'm gonna run it from dnSpy, and what I'm gonna do is I'm gonna try to see if we can reach where either the create instance or invoke member is being called, and then that's gonna help us to basically identify the method name, the method and the class being used to jump into the second stage. Okay, so let's try to do that. I'm gonna stop this debugger, which was the previous one. Okay, then I'm gonna come here, I'm gonna click start. Okay, let me maximize this guy. 1 second. I maximize this guy again. So now, guys, what I'm gonna do is I'm gonna start step into. Okay, but before doing that, guys, I wanna show you something pretty cool from dnSpy. As you saw, we were doing CLR stack in WinDBG to see the full call stack, and here is the same. If I go to this guy, right, and I do right click, analyze, okay, it's gonna tell me who calls this guy, right? It starts searching and it's trying to find who called this load guy, which we identify in WinDBG just a few seconds ago, but here is exactly the same in dnSpy. So we can go backwards in the call stack. Now, who called this guy? Oh, this guy calls the previous one. And now, who called this guy? The previous one, and so on, so on. So this is also pretty cool in dnSpy, because now we can go backwards and understand the full flow of execution. Okay. So so now that we run the debugger, so we are here. I'm gonna do F10. By the way, sorry, I was here, so I want to do another continue so that we can hit our breakpoint. It is running. So we hit our breakpoint right here. We know that this is going to load the binary, so I just do a F10 to go over. And if we go here to locals, guys, and we go to the, let's see, what is the assembly? It should be around here. Here it is. It is loaded already in memory, you see. And here is the full content. You can see here the size V400, you remember? So we can do right click here, show in memory, and you can see that here we have the full binary. Also a different path that we use in WinDBG, but same result. Obviously we were not able to do this before because what we explained of the obfuscation and limitation, but thanks to the WinDBG trick we can do it now. Okay, so what I'm gonna do right now, guys, is I'm gonna just step into with F10. I don't wanna go in as before. I just wanna go quickly to see if there is any invoke member and see if we can spot it quickly. Okay, so I do an F10 here. We go here. In this function, we just do F10. You know, it's same thing. It's jumping in the switch cases. We go here. Something very important, guys, that I recommend is that even though you are doing F10, you always check what is the result of that function, right? You don't just go blind. So I do F10 here, and then I want to check what is in the array. Here is the array. Click here, and see, guys, we just got all the classes from that assembly. If you remember what was the method to do that, I'm gonna give you a coin. Okay, get types. Way to go. You can see it. We didn't get inside that, but we figured it out faster. Okay. Okay, so I keep going. I'm gonna do F10. There is num4. It goes to L1. It says if num4 is greater than array. Array, keep in mind, guys, is all the classes that we are seeing here. So, and then array has, number has 0. Okay, so then we do F10. Check if it is a class. The type. What is the type? Oh, here is the type. It's saying that class 1, if it is a class, it says yes, it is a class, then it goes here. We don't know what it is here, but we know that it is passing the type, you know, class 1, and then gets into the result something. We do F10, we see that the result is null. Okay, so then again we go there. Again, num4 now is 1. It keeps incrementing, and then it gets here the next type, which is now class 2. And then checks if it is a class. Okay, and then keep jumping, and here again it's gonna pass the type, which is class 2, and the result, if we run it, is null. Okay, I will lose it here. Okay, anyways, let's do it one more time. So again, array is the same. Now we got class 3, and same thing, you know. We do result is null. So something is going on here. So let's just put a breakpoint here, and let's go fast. So we do continue. We get messenger F10, result is null. We do continue. We get new RP F10, null 0. We do continue. We get back F10, null 0. We go continue. We get this do doc co. We do F10, and check this, guys. We were doing F10, the debugger stops suddenly, and just something happens here. Okay, and that happened when it was calling the do doc co, if you remember. So it never returned back, and plus we might be already infected. Let's check it. This is taking also a lot of time. Okay, so let me do this. See, 90% being consumed by this guy. This guy, if you remember, is the name of the first stage. So what happened here, guys, is that we accidentally run it, the malware. But since we are in a VM, there is no problem. But the learning thing here, guys, is that we found something here. So now what we're gonna do is we put a breakpoint here and we restart the efforts. Okay, so we hit there, we hit in the load. I'm gonna remove this breakpoint because I don't need it. Continue. We hit here again, guys, and as you remember, it has class 1, then class 2, 3, fixes, messenger, new RP, pack, and then do the co, which was the one that didn't came out. So let's do an F11. We get inside, and then we do exactly the same process, guys. F10 to go quickly. Okay, it does something here. We don't know what it is. Okay, we keep going. We can go into the flow. Then it calls these two guys. Okay, and there is nothing that is returning. okay, equals to num4. Then we go to this guy again and see here we do an F10 and boom, again it's running, it's doing something and stops the debugger. So it looks like something happens here. So again I put a breakpoint there, I kill the malware again, and what else? That's it. Okay, so now I'm gonna restart again debugger, but now from here. As you can see, we're going F10 quickly, and then if it is needed we need to dig into. Okay, so we run this guy, we hit the previous one, we already get this one, so I'm gonna remove the breakpoint, I do continue, and now we hit this guy which was doing something bad. And as you can see guys, there is something important here. We have the class SSALDIM .udo.co, which is the method which looks like this guy is actually being used as the main one, but we need to confirm that. Okay, so here I'm going to do F11 so that we don't get out again, and we go back to our methodology. Let's do F10 quickly. Okay, we go there, we go there, we go there. Okay, we reach here, then we reach here, num. Okay, so I'm getting tired. Probably this was not the best approach. Okay, so then we reach here, target guys, check here. It executes this, and then the target, what is the target here? See, we now have as a target the class and method that potentially might be called. Let's keep going. This is giving us fuel because we were about to give up, right? Okay, we get here, we do F10, and see these guys. We get into invoke member, and as you remember, the invoke member has the argument method and the class to be called and the arguments. So I do F11. By the way, here I don't know what is this 20, can be any of these guys. So let's confirm what it is. So I do F11, okay, here is binding defaults. I just step into a different one, which is just the parameters of the invoke member. So again, I just step out here, I do F11 again, and here guys, finally we can see that the invoke member, which is gonna call in the first argument the method name, bingo, we got the method name, we got the class. So now guys, we finally found what is the entry point. So if we go to our DLL, let me find it, maybe it just went out. No, just kidding. So here it is. This is the function, initial one, that now is going to be called. So now from here guys, now I feel comfortable that now when it's the next step to do analysis, we know exactly what is the entry point. Okay,